Here's a lesson for section 6.4, parallel and perpendicular lines. Before we start this lesson, I just want to remind you what a parallel line is and what perpendicular lines are. So parallel lines, if you are to graph two lines and those two lines will never meet, they'll never intersect, we say that those lines are parallel. But if you graph two lines and those two lines intersect at a 90-degree angle, then we say those lines are perpendicular. So, for example, parallel lines, two lines that when you graph them, they will never meet. Okay, like those two lines. Perpendicular lines are lines that intersect at a 90-degree angle. So let's start off just by graphing a few lines and being able to analyze the graph and determine which lines are parallel, which lines are perpendicular. And then we'll compare the slopes of each of the lines that are parallel and perpendicular and try and find a trend. So let's start off by graphing this first line, y equals 2x plus 4. So remember the equation of a line is y equals mx plus b, where m is your slope and b is your y-intercept. Okay, so if I have the equation y equals 2x plus 4, my slope is 2. I'm going to write that as 2 over 1 so that we can clearly see our rise and our run. And our y-intercept, our b value, is 4. So if I'm going to graph this line, the steps to graphing a line are to firstly plot the y-intercept. So it crosses the y-axis at 4, and then it has a slope of 2 over 1. So that's my rise over my run. So I know I have to rise 2 and run 1. That means go up 2 and right 1 from my y-intercept. So from my y-intercept at 4, I'm going to go up 2 units, and then right 1 unit, and there's my next point. And then keep doing this. So from that new point, go up 2, right 1 again, up 2, right 1 again. And now let's plot points to the other side of the y-intercept. So instead of going up 2 and right 1, I'm going to do the opposite. I'm going to go down 2 and left 1, and that'll give me points to the other side of the y-intercept that are still on the same line. And then I'll continue doing this until I've maxed out the graph. So down 2, left 1, keep going, and there we go, I've maxed out the graph. And now what I want to do is I want to connect all of those points with a straight line. So I'm going to zoom out just so I can get the straight line through all of the points. And then this is the graph of y equals 2x plus 4. And as you notice, this line slants up to the right. Okay, it goes up to the right because we have a positive slope. If you graph a line and you have a positive slope, it should be going up to the right. If it goes down to the left, then you've used the wrong slope. Okay, you've done your rise and your run improperly. If you have a negative slope, like our next line. Whoops. No, I want to redo that. If you have a negative slope, like line B here, we know this line is actually going to slope down to the right. Okay, let's graph this line. So this line, line B, it has a slope of negative 1 over 2. So I'll just jot that down. The slope is negative 1 over 2, negative 1 over 2. Now you could use negative 1 over positive 2 or positive 1 over negative 2. Both of those are equivalent. Depending on which one you use, that will just determine whether you plot points to the right or left of your y-intercept, but both those slopes will give you points on your line. And my y-intercept is negative 6. So what you do to graph a line, firstly plot your y-intercept, so it crosses the y-axis at negative 6, and then I'll use my slope negative 1 over 2. That's my rise over my run, so I have to rise negative 1, that means go down 1, and then right 2. So this is my point right here. And then keep going from that point, down 1, right 2 again, down 1, right 2 again, down 1, right 2 again. Now if I want points to the other side of my y-intercept, I'm going to do the opposite of down 1, right 2, and that's up 1, left 2. And that's exactly what the slope of 1 over negative 2 tells you to do. That's your rise. So rise of 1 means up 1. Run of negative 2 means left 2. And that's exactly what we're doing to plot points to the other side of the y-intercept. Up 1, left 2, up 1, left 2, left 2, up 1, left 2. And there's this line. And now I'm going to connect all of these points with a straight line so I can see the graph of that line. There we go. I should be labeling these lines. So this was line B. This line up here was line A. And lastly, I'm going to graph line C. So for line C, it's actually got the same slope as line B. So it's negative 1 over 2 as well. or you could use 1 over negative 2. Those are both equivalent. If you typed both of those on your calculator, you would get the value negative 0.5. They're both equivalent. It just determines whether you plot points to the left or right of your y-intercept. And we're going to end up using both of them so that we can plot points that will fill up our whole graph. And the y-intercept is 8. So what we want to do to graph the line, plot your y-intercept at 8. Then use your slope of negative 1 over 2. That's a rise of negative 1, so down 1. And a run of 2, so right 2. And then keep going. Down 1, right 2, down 1, right 2. And then to plot points to the other side of the y-intercept, the opposite of going down 1 and right 2 is up 1 and left 2. And that's what our slope of 1 over negative 2 tells us to do. Rise 1, left 2. Rise 1, left 2. And there I've maxed out my graph. Connect those points. Whoops. There we go. Perfect. Okay. So I have my 3 lines. What the next question is going to ask is to say, it says which lines are parallel. So which of these 2 lines, so this is line C. Which of the 2 lines on this graph, I'll zoom out so you can see them all. What 2 lines on this graph are parallel? So when I say parallel, I mean which 2 lines on this graph will never meet. If I keep drawing them forever, which 2 lines will never meet? Well, in fact, it's lines B and C. Those 2 lines will never meet, okay? This line B is going like this. This line C is going like this. If I were to draw these lines forever, they would never touch. Therefore, those lines are parallel, okay? So which lines are parallel? B and C. What do you notice about the slopes of the lines that are parallel? So B and C are parallel. Let's take a look at the slopes of B and C. The slope of B was negative 1 over 2. The slope of C was negative 1 over 2. So the slopes of parallel lines are the same. So if 2 lines have the exact same slope, their lines are parallel. Okay? So what do you notice with the slopes of lines that are parallel? They are the same. Which lines are perpendicular? Okay, so which lines on the graph intersect at a 90-degree angle? Well, what you should notice is lines A and C, they intersect at a 90-degree angle, and lines A and B also intersect at a 90-degree angle. Okay, so line A is perpendicular to both C and B. Okay. Which lines are perpendicular? A is perpendicular to B and C. What do you notice about the slopes of lines that are perpendicular? Well, the slope of line A was 2 over 1. The slope of line B was negative 1 over 2. So what you should notice is the slope of 2 over 1 and the slope of negative 1 over 2 are what we call negative reciprocals. And what that means is, to find a perpendicular slope, if your original slope is 2 over 1, a slope perpendicular to that would be flipped. So the fraction would be flipped. So the perpendicular slope, there's a sign for perpendicular. The perpendicular slope would be this slope flipped, so flip the slope, and then change the sign. So if the original slope was positive, then the perpendicular slope is going to be negative, and vice versa. If your original slope was negative, then your perpendicular slope will be positive. Okay, so what we want to say, I'm not sure why it's flashing like this. What do you notice about the slopes of lines that are perpendicular? They are negative reciprocals. And if, I'll read the next question first. So what is the product of perpendicular slopes? Okay, so if you don't notice that 2 slopes are negative reciprocals of each other, remember negative reciprocals just mean that the slope has been flipped and the sign has been changed. And sign changed. Okay, that's what negative reciprocal means. Flipped and the sign has been changed. So the numerator is now in the denominator and vice versa, and if it was positive it's now negative, or if it was negative it's now positive. Okay? So what do you notice about the product of these slopes? Well, if you can't notice the negative reciprocals, just multiply the 2 slopes together. So multiply, the slope of A was 2 over 1. the slope of b was negative 1 over 2. Multiply the slopes together, and if their product is negative 1, that will tell you that they are in fact perpendicular lines, and the slopes are in fact negative reciprocals of each other. So let's check that. So when you're multiplying fractions, multiply the numerators. 2 times negative 1 is negative 2. Then multiply the denominators. 1 times 2 is 2. You get negative 2 divided by 2, which is equal to negative 1. And that will always be the product of perpendicular slopes. Does the y-intercept matter when deciding if two lines are parallel or perpendicular? No, you notice we haven't talked about the y-intercept really at all. All we're interested in is the slope, and we're comparing the slopes. If the slopes are exactly the same, as in the case of lines B and line C, then we have parallel lines. If the slopes are negative reciprocals of each other, as in the slopes of A and B, or A and C, then you know we have perpendicular lines. The y-intercepts don't matter. That's not going to affect the slope of the line at all. It's just going to affect where it crosses the y-axis. So what we'll say for number 6 here, does the y-intercept matter when deciding if two lines are parallel or perpendicular? No, it doesn't matter. So let's consolidate what we just learned here. Parallel lines have, we could say identical slopes or the same slopes. I'll say equivalent slopes. I'll say that. Actually, I'll say identical slopes. Parallel lines have identical slopes. They are exactly the same. Okay. Perpendicular lines have slopes that are negative reciprocals. Okay. And once again, that means that if your original slope, let's say, is 2 over 3, the perpendicular slope, okay, so that's our original slope, perpendicular slope, and once again, this is the perpendicular sign, two perpendicular lines. The perpendicular slope would be the flipped version of the original slope, so put the numerator in the denominator and vice versa, so it becomes 3 over 2, and then change the sign. So the original slope had a positive value, so this slope has to have a negative value. Okay. If our original slope, let's say our original slope was negative 2 over 3, negative 2 over 3, the perpendicular slope would become positive 3 over 2. Okay? Since the original slope had a negative value, the perpendicular slope would have a positive value. And once again, the fractions have been flipped. Don't forget that part. And also I added in here, don't forget you can check to make sure two slopes are perpendicular to each other by checking to see if the product of the two slopes is negative 1. Perpendicular slopes always have a product of negative 1. Okay, let's start doing some examples. So the equation of a line is y equals 3x minus 4. What is the slope of a line parallel to this line? Well, remember, parallel lines have identical slopes. So the equation of a line is y equals mx plus b. So this number here in front of the x, the 3, is in fact the slope of the line. So the slope of this line is 3. What is the slope of a line parallel? Well, parallel lines have identical slopes, so the slope of a parallel line would also be 3. Okay, part B. The equation of a line is y equals negative x plus 15. What is the slope of a line that is parallel to that? Well, the slope of this one, all I see is negative x. I don't see a number in front of the x, I just see a negative sign. So remember, there's actually a negative 1 there. It's actually negative 1x plus 15. So the slope is in fact negative 1 of that line. Any line parallel to this line here is going to have the exact same slope. So it'll have a slope of negative 1 as well. If the equation of a line is y equals 2x plus 1, what is the slope of a line perpendicular to this line? Well, the slope of this line is 2. Therefore, the perpendicular slope is going to be the negative reciprocal of that. So the perpendicular slope equals, well, the original slope was 2. I'll write that as 2 over 1. The perpendicular slope, I must flip the fraction and then change the sign. So the original slope was positive, so this slope is going to have a negative value. And there's my perpendicular slope. D, the equation of a line is y equals 3 over 5x plus 2. What is the slope of a line perpendicular to this line? So once again, I'm looking for a perpendicular slope to this line. This line has a slope of 3 over 5. A slope perpendicular to that, I must flip the fraction and change the sign. So I must give the negative reciprocal. So it would become negative 5 over 3. And once again, don't forget, you can check to make sure that you've done this properly, because the two slopes that we have here, the slope and the perpendicular slope, if we've done it properly, they'll have a product of negative 1. Let's check that. 3 times negative 5 is negative 15. 5 times 3 is 15. And then negative 15 divided by 15 equals negative 1. Therefore, we've done it right. This is good. Okay, D. The equation of a line is y equals negative 1 over 7x minus 3 over 7. What is the slope of a line perpendicular to this line? So the slope of this line is negative 1 over 7. A slope perpendicular to that is the negative reciprocal of that. So I must flip the fraction. So instead of 1 over 7, it's going to become 7 over 1. And then, since our original slope has a negative value, this slope is going to have a positive value, so I'm going to leave that there. I don't need to put a negative sign anywhere. So 7 over 1, I could simplify that to just 7. 7 divided by 1 is 7. Okay? And there we go. There's our perpendicular slope. Example 2. The slopes of two lines are given to determine whether lines are parallel, perpendicular, or neither. So let's look at the first set of slopes. Okay? In part A. A slope of 3 and a slope of negative 1 over 3. Those are in fact negative reciprocals of each other, so they're perpendicular. If you don't notice that, what you can do is multiply them together and check if the product is negative 1. So let's check that out. So our first slope, I'm going to write it as 3 over 1. That makes the multiplication easier. So let's check the product. 3 over 1 times negative 1 over 3. That gives us negative 3 over 3, which equals negative 1. Therefore, they're perpendicular. That means if you were to graph these two lines, they would intersect at a 90-degree angle. Okay, so I've got a slope of 5 and a slope of negative 5. Well, these 5 and negative 5 aren't the same number, so they can't be parallel, so they're not parallel. The only other thing that might go through your mind is you might think that they might be perpendicular. In fact, they're not, but just to check what you could do, you can multiply them together and check if their product is negative 1. So what's 5 times negative 5? Well, that's negative 25. And negative 25 is not negative 1. Therefore, they're not perpendicular either. Another way you can check, you can just think to yourself, oops, I didn't mean to erase that. You can just check to yourself, so if your original slope is 5, what slope would be perpendicular to 5? Well, think of this as a 5 over 1. Perpendicular to this, you'd flip the fraction and then change the sign. It would be negative 1 over 5. Okay? So this and this are not equivalent, so they can't be perpendicular. Okay? So in this case, these two lines, or these two slopes, are neither parallel or perpendicular. So neither. Part C, a slope of 6 and a slope of 1 over 6. Well, they're not parallel because they're not the same slope. You can check, maybe they're perpendicular. You should know a slope that's perpendicular to 6 would be the slope that has been flipped. So it has become 1 over 6 and the sign has been changed. So it should be negative. This slope right here is not negative 1 over 6. It's positive 1 over 6. So these lines are neither parallel or perpendicular either. Another way you could check, you can multiply your slopes together. So 6 over 1 times 1 over 6. Check and see if the product equals negative 1. In this case, the product is actually positive 1. So that's not equal to negative 1. Therefore, they're neither as well. Okay. So neither. How about D, a slope of negative 2 and negative 2? Those are identical, so these lines are parallel. If you were to graph these two lines, so I graph these two lines, they would be lines that would never meet. Okay? You could graph them forever, and they would never cross each other. Okay, example 3. Determine the slope of a line that is parallel to this line that's given here. Now this line is given to you in standard form, so we can't tell the slope just by looking at this line. So what we want to do is we want to rearrange this equation into y equals mx plus b form so we can figure out what the slope of this line actually is. So let's rearrange it. So what I want to do, so I'll just rewrite it here. 2x minus 3y minus 6 equals 0. I want this to look like, over here, I want it to look like that, okay? So what I need to do, I need to get y by itself on the left, and then move the term with the x to the right, and the constant term to the right as well. So I'm going to start by isolating the term with the y. So I'm going to get the negative 3y by itself by moving the 2x to the other side, it becomes a negative 2x, and move the negative 6 to the other side, it becomes a plus 6. Now I'm going to get the y by itself. Right now it's being multiplied by negative 3, so I must divide both terms on the other side by the negative 3. So negative 2 divided by negative 3x plus 6 divided by negative 3. Now I'll simplify. Negative 2 divided by negative 3, the negatives cancel out, so that's just 2 over 3x. And then 6 divided by negative 3 is negative 2. So there's the equation of the line. What's the slope of a line parallel to this one? Well, this line has a slope of 2 over 3, so a line parallel to that would have a slope that is identical to that. So it would also be 2 over 3. Okay, let's do B. Find the slope of a line perpendicular to that line. So if the slope was 2 over 3, I've already rearranged it, I don't have to rearrange it again. If the slope was 2 over 3, a line perpendicular to that would have a slope that is the negative reciprocal of this. And what that means is, so the perpendicular slope would have a negative, is going to be the negative reciprocal of that one, so I must flip the fraction and change the sign. So the overall value of this fraction was positive, so the overall value of the perpendicular slope is going to be negative. And you can check and make sure that you've done this properly by multiplying these two together and making sure you get a product of negative 1. 2 times negative 3 is negative 6, 3 times 2 is positive 6, negative 6 divided by positive 6 is negative 1, so you've done this one right. Alright, next question. Oh, so I think we're done. What we're just going to do, just consolidate a little bit. So if you've got two parallel lines, this is what they would look like on a graph. They would be two lines that no matter if you graph them forever, they will never intersect each other. And parallel lines have identical slopes. Okay, so these ones would have the same slope. Perpendicular lines, if you were to graph them, where they intersect would form a 90-degree angle. And that's what that little square indicates there, that's a 90-degree angle. And their slopes are negative reciprocals. So slopes are negative, I'll just write a short form, negative reciprocals. Okay, and they have the slopes have a product of negative 1. Okay, explain how you can determine if the two lines 3x minus 4y minus 12 equals 0 and 4x minus 3 minus 24 equals 0 are parallel, perpendicular, or neither. What you would have to do to start off with, you'd have to rearrange them into the form y equals mx plus b, into slope y-intercept form, so that you can tell what the slopes of those two lines actually are. And then after you've done that, compare the m values of the two lines. So compare the slopes. Compare slopes and check if they are the same. They are the same or negative reciprocals or neither. If the lines have identical slopes, then they're parallel. So if the same slopes, they're parallel. Negative reciprocal slopes, then they're perpendicular. If neither of those are true, that they're not the same and they're not negative reciprocals, then the two lines aren't parallel or perpendicular. They're neither. And how would we determine? So now part B actually says determine if the two lines are parallel, perpendicular, or neither. Sure, let's do that. So let's rearrange the first line into y equals mx plus b form. So I'll isolate the term with the y. So get the negative 4y by itself, move the 3x to the other side, becomes a negative 3x, move the minus 12 over, becomes a plus 12. Now isolate the y by dividing the negative 4 to the other side. So negative 3 over negative 4x plus 12 over negative 4. And then simplify. The negatives cancel out. And 12 divided by negative 4 is negative 3. Now let's do this line. Let's rearrange this one. So isolate the term with the y first. Move the 4x to the other side, becomes a negative 4x. Move the minus 24, becomes a plus 24. Then isolate the y. Right now it's being multiplied by negative 3. So on the other side I must do the opposite, which is dividing by negative 3. And if I simplify this, negative 4 divided by negative 3, the negatives cancel. I'll just write that as 4 over 3x. And then 24 divided by negative 3 will give me negative 8. Now, let's look at the slopes of these two lines. The slope of this line is 3 over 4. The slope of this line is 4 over 3. So, in fact, these lines are neither parallel or perpendicular. The slopes are not the same. Okay, 3 over 4 is not equal to 4 over 3, so they're not parallel lines. And they're not negative reciprocals either. A slope perpendicular to 3 over 4, so a slope perpendicular to this one, you would have to flip it, so 4 over 3, but you would also have to make it negative. You also have to change the sign. This slope here, the sign was not changed. It's a positive 4 over 3, so it's not perpendicular. Okay? And what you can do just to check to make sure they're not perpendicular, multiply them together and check and see if their product is negative 1. So 3 over 4 times 4 over 3, that gives you 12 over 12, which equals positive 1, which is not negative 1. Therefore, they're not perpendicular either. So they're neither parallel or perpendicular. So your final answer for this, are they parallel, perpendicular, or neither? They are neither. So what you can do now, go to jensenmath.ca and download the worksheet and make sure you try it and let me know if you have any questions.